the way the chapter is written is quite haphazard. Therefore, I'm going to follow my own sequence. And first, I will explain a lot of things about what is electricity and then jump on to textbook. So bear with me and focus. This is a foundation chapter. Foundation chapter means this is for the first time you are understanding electricity. And if you like it, if you understand it properly, possibility is you will become a good electrical engineer, a good electronics and telecommunications engineer, a good person into IT, information technology, because this is the base. Without electricity, our world is zero. And therefore, it's important to understand it. It's for the first time you are understanding it. So focus, pay attention. It's a foundation chapter on electricity, जो future में पूरा एक subject बन जाएगा if you choose that stream of science. But I'm going to try to explain you in such a way that everybody understands. Engineer or a chartered accountant or a dhobi, everybody should be able to understand. That's the job of a teacher. So try to understand electricity first. Don't worry about science, commerce, or dhobi. Define electricity. The definition of electricity is just 3 words: flow of charge. Electricity is flow of charge. What is flow of water called? What is flow of blood called? Flow of water, we call it a river. Flow of blood happens inside the nerves of our body, the veins and arteries. Similarly, flow of charge is what happens inside a wire, which is called electric current. तो इलेक्ट्रिक करंट का मतलब होता है फ्लो ऑफ चार्ज. जैसे रिवर इज फ्लो ऑफ वाटर एंड वेन्स और आर्टरीज में फ्लो ऑफ ब्लड. नाउ फ्लो ऑफ ब्लड has a deeper meaning. Flow of water has a deeper meaning and flow of charge has a deeper meaning. We are going to compare the word blood, water and charge. Flow of blood का मतलब है flow of red blood cells, RBCs. जब लाखों करोड़ों RBCs एक वेन में से निकलते हैं तो we call it as flow of blood. But microscopically, when you look inside, what is flowing? The red blood cells are flowing. When we say flow of water, but what is actually flowing? It's flow of H2O molecules. Water is made up of water molecule. And when we say flow of charge, what is flowing? It's technically flow of electrons. Blood flows मतलब उसके अंदर RBCs are flowing. Water flows means उसके अंदर के water molecules are flowing. Flow of charge is flow of electrons. इसका मतलब ये है that electrons have a charge. Yes, electrons have a charge. What kind of charge? A negative charge. तो पॉजिटिव चार्ज किसके पास है? प्रोटॉन्स के पास. So electrons have positive and negative. Electrons have negative charge. Protons have positive charge. And when electrons start to flow, we call the charge has started to flow. Okay. Flow. तो फ्लो वर्ड तो समझ में आ गया. फ्लो होने के लिए जगह चाहिए. इलेक्ट्रिसिटी फ्लो करने के लिए जगह कहां से आती है? वायर में से a metal wire, what is it made up of? A metal wire is made up of atoms of metal. Let's say copper. So copper wire is made up of copper atoms, fully, entirely of copper atoms. No space, tightly packed, और उसमें से copper wire बनता है. But copper atoms, we know the structure of atom. The structure of atom is something like this. There is a central nucleus which is positively charged of copper, and around the central nucleus, which is very heavy because protons and neutrons are heavy, there are orbits, and around the orbits there are electrons. रूटीन लाइफ में मेटल के वायर को टच करो तो करंट लगता है. यू टच अ पीस ऑफ मेटल. दिस इज अ थर्मोमीटर. थर्मोमीटर का टिप इज मेटल, एंड व्हेन यू टच करंट लगता है? नहीं. इसके अंदर सेल है, फिर भी करंट लगता है? नहीं. बिकॉज करंट इज नॉट इलेक्ट्रॉन्स. Current is flow of electrons. The electrons have to flow in order for the current to exist. What is the biggest difference between river and a lake? The biggest difference is the word flow. जहां पानी देखा वहां नदी नहीं. जहां पानी देखा वहां नदी नहीं होती है, क्योंकि जहां पानी है वो फ्लो नहीं कर रहा है तो उसको लेक बुलाते हैं. बट इफ इट इज फ्लोइंग तो वो नदी है. सो फ्लो इज इंपॉर्टेंट, फ्लो ऑफ इलेक्ट्रॉन्स. बट हियर, एज ऑफ नाउ, द इलेक्ट्रॉन्स आर नॉट फ्लोइंग. इट इज जस्ट अ सिंपल पीस ऑफ कॉपर वायर. कॉपर के वायर का एक टुकड़ा है जो मैं समझाने की कोशिश कर रहा हूं. कॉपर के वायर का टुकड़ा कॉपर से बना है. कॉपर के अंदर कॉपर का न्यूक्लियस है, और कॉपर के न्यूक्लियस के इर्द गिर्द ऑर्बिट्स है, और ये सारे ऑर्बिट्स ओवरलैप होते हैं बिकॉज कॉपर एटम्स आर टाइटली पैक्ड. और ये ऑर्बिट्स के अंदर घूम रहा है इलेक्ट्रॉन्स. इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड द ऑर्बिट्स इन दिस कॉपर एटम्स, और वो कॉपर एटम्स ज्वाइन करके कॉपर वायर बनता है जिसमें कोई करंट लगता नहीं. इज देयर इलेक्ट्रिसिटी राइट नाउ? नो. इलेक्ट्रॉन्स कहाँ है? Say these are the electrons randomly moving around in every orbit. कितने हैं, कहाँ है, कैसे हैं, वो सब जानने की जरूरत नहीं है. Every metal wire has protons, electrons and neutrons because it has atoms. Atom है तो ये तीनों चीज होगी. क्यों शॉक नहीं लगता? फर्स्ट आंसर, व्हाई टचिंग अ मेटल डज नॉट गिव यू एन इलेक्ट्रिक शॉक और इलेक्ट्रिक करंट. The electrons are flowing round, 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 round. No, that's not called flowing. That is just movement. And look at this photograph. This is random motion of electrons. Some electrons are moving up, some are moving right, some are moving down, some are moving left, right, etc. inside metal. And because of his random motion, electric current is absent because charge कुछ लेफ्ट जा रहे हैं, कुछ राइट जा रहे हैं, इसलिए एक दूसरे को नलीफाई कर देते. चार्जेस आर मूविंग लेफ्ट एंड राइट, therefore they nullify each other like balanced forces. याद है, balanced forces से चीजें मूव नहीं करती because balanced forces nullify each other. So this is no current. This is routine metal. But what happens when you attach that metal with अ बैटरी, ये मेटल के टुकड़े को, ये वायर को हम दूसरा वायर लेके बैटरी के साथ अटैच कर देते, पेंसिल सेल. दिस इज माइनस टर्मिनल ऑफ द बैटरी, दिस इज पॉजिटिव टर्मिनल ऑफ द बैटरी, और ये वायर लेके यहाँ पे कर दिया ज्वाइन. द मिनट यू डू दिस, all the electrons of the metal start marching in one direction. वायर के अंदर के सारे इलेक्ट्रॉन्स जो रैंडमली घूम रहे थे, they have now suddenly started to march in a single direction, and that is this direction. They are jumping from one atom to another and continuously jumping and flowing, and this is called electric current. इसको हाथ लगाओगे तो शायद शॉक लगेगा अगर हाई अमाउंट ऑफ करंट विल बी देयर, और छोटा करंट होगा तो थोड़ा सा tingling effect होगा, but you will feel that yes, there is current passing. Why did this happen? बैटरी में ऐसा क्या स्पेशल है that it started forcing the electrons to march in one direction? The answer is battery has electric potential, जो एक कॉमन भाषा में जो धोबी को भी समझ में आएगी, I call it a push. धक्का मारोगे तो एक तरफ जाएंगे ना. Imagine there is a big herd of cows or a big herd of buffaloes. You have to control them. You have to push them in such a way that they all continuously move in a single direction. वैसे, for electrons to move in a single direction, you need a push. And that push is given by the battery, and it is called electric potential. कैसे बाद में दें? बैटरीज कहाँ बनती है? फैक्ट्री में. कैसे बनाते हैं बैटरी? बैटरी is nothing but a piece which has a lot of electrons inside, and those electrons used to be equally distributed. अगर electrons equally distributed है तो वो बैटरी में दम नहीं है. This is the dead battery. But what does a factory do to manufacture a battery? फैक्ट्री क्या करता है? ये केमिकल जिसके अंदर सारे इलेक्ट्रॉन्स इक्वली पथराएले हैं, उसकी जगह पे एक कंपार्टमेंट क्रिएट करता है और सारे इलेक्ट्रॉन्स को यहाँ पे ठूस देता है. ठचो ठच. दे आर हेवीली फिल्ड इनसाइड, जगह ही नहीं. एंड एट द सेम टाइम दिस इज एम्प्टी, ये खाली है. और अगर ये एक कंपार्टमेंट खाली और दूसरा इलेक्ट्रॉन से ठचोठच भरा हुआ, तो इलेक्ट्रॉन ब्रिंग्स नेगेटिव चार्ज, देयरफॉर दिस इज नेगेटिव टर्मिनल, एम्प्टी इज पॉजिटिव टर्मिनल. तो ये बैटरी के अंदर द इलेक्ट्रॉन्स आर डाइंग टू कम आउट क्योंकि जगह नहीं. बट वेयर विल दे कम आउट? देयर इज नो स्पेस. बट द मिनट वी अटैच a wire to the battery, electrons get a chance to jump on the wire. Electrons को बाहर निकलने का चांस मिलता है और वो फ्लो करने लगते. They are happily running. Imagine there are 500 birds in a single cage. When that cage is opened, won't the 500 birds start flying away? Yes, one by one. They will start to fly away where there is space. और इलेक्ट्रॉन्स को मूव करने की जगह वायर के ऊपर होती. Therefore, the electrons have started to move, and they are all marching in one direction. It's like passing the parcel. आगे जाके करंट स्टॉप होगा, फ्लो स्टॉप होगा? नहीं, because this empty compartment has so much space. कि वो इलेक्ट्रॉन को ओपन इनविटेशन दे सकता है, आते जाओ आते जाओ आते जाओ, बहुत जगह है। देयरफॉर यहां से इलेक्ट्रॉन निकलते जाओ और यहां से आते जाओ। Therefore, the battery is able to create a push because of this reason. And in language of science, it is called electric potential या electric potential difference. तो बैटरी ने दो कंपार्टमेंट की वजह से एक ऐसा सिचुएशन खड़ा किया जहां पे इलेक्ट्रॉन स्टार्टेड टू कम आउट फ्रॉम द नेगेटिव टर्मिनल एंड स्टार्ट टू ट्रैवल टू द पॉजिटिव टर्मिनल, hence giving us electric current. This is flow of electrons. Every electron has a charge. Therefore, it is called flow of charge. And flow of charge is called electric current. Hope itna samajh mein aaya. Let's take the first step towards class presentation. Electric current and circuit. We are familiar with air current and water current, flowing air or flowing water. Here we have flowing electrons, and flow of electrons happens only in metallic wire because it's a good conductor of electricity. Who creates electric current? The battery. How? When it is placed in a proper order. And battery gives current, but current gives what? Current gives us everything what we want. Depends कि हम करंट के रास्ते में किसको फिट कर रहे हैं, अकॉर्डिंगली हमको वो चीज मिलेगी. फॉर एग्जाम्पल, this is the wire. The wire is attached to a battery. बैटरी का ये कंपार्टमेंट नेगेटिव है, ये कंपार्टमेंट पॉजिटिव है, ये ठच इलेक्ट्रॉन से भरा हुआ है. Try to answer my one question right now by looking at this figure. Is the current flowing? Answer is no. The current is not flowing because the circuit is not attached to each other. इलेक्ट्रॉन फ्लो करने के बीच में गैप है, और अगर गैप है तो इलेक्ट्रॉन्स कैन नॉट फ्लो. देयरफॉर राइट नाउ इलेक्ट्रिसिटी स्टॉप्ड. अगर मैं डायरेक्ट ज्वाइन कर दूंगा तो यहाँ के सारे इलेक्ट्रॉन्स भाग के यहाँ आ जाएंगे, बैटरी हो जाएगी खत्म, और मुझे कुछ फायदा नहीं होगा. मुझे फायदा तब होगा जब ये गैप के बीच में मैं कोई ऑब्जेक्ट लगाऊं, जैसे एक बल्ब. If I attach a bulb in the middle of the wire, then the electron starts to flow. And when the electrons are flowing, रास्ते में आ जाता है bulb, और अगर electrons flow through the bulb lights up, giving me light energy. But मुझे light नहीं चाहिए, तो मैं यहाँ पे सर्किट के बीच में एक रेडियो लगा देता हूँ. If I put a radio, then what will happen? The electrons will start its journey from the battery and they start flowing through the wire. वायर के थ्रू वो रेडियो के पूरी सर्किट के अंदर से गुजर के बाहर निकल जाता. And that tells me that the radio is working. I start getting sound. I can put anything here and make it work. That's called electricity. Electric current I, electric potential V. दो सिंबल याद रखना. तो मैं बल्ब लगा के लाइट दे सकता हूँ, रेडियो लगा के साउंड, टीवी लगा के एंटरटेनमेंट, कंप्यूटर लगा के वर्क. लॉट ऑफ थिंग इज पॉसिबल. लेट्स डिस्कस व्हाट इज द डायरेक्शन ऑफ इलेक्ट्रिक करंट. फिर से एक बार, I take a battery which has two compartments, negative compartment, positive compartment. नेगेटिव कंपार्टमेंट ठचोठच इलेक्ट्रॉन से भरा हुआ है and electrons are negatively charged. When I take a wire, let it pass through a bulb and attach back to the battery, electrons negative compartment में से बाहर निकलेंगे and they will jump onto the wire, and from there they will keep jumping ahead through the bulb back to the wire and reach the positive terminal of the battery. Therefore, अगर कोई मुझे पूछे A, B, C, D, अगर कोई मुझे पूछे what is the flow of electrons, direction of flow of electrons, my answer will be A to B to C to D. But बहुत साल पहले when we did not know electricity, तब ऐसा बिलीव करते थे that it is not electrons which move, it's the protons which move. इलेक्ट्रिसिटी को ऐसा माना जाता था that electricity is flow of protons, and flow of protons is always from positive terminal to the negative terminal. मतलब D to C, C to B, B to A, and A back to the battery. Therefore, flow of current at that time was considered as ulta, D to C to B to A. बाद में पता चला कि फ्लो ऑफ इलेक्ट्रॉन्स होता है, फ्लो ऑफ प्रोटॉन्स नहीं. But it was too late. It was too late because in hundreds and thousands of documents, magazines, scientific journals, scientists, books, it was all printed that flow of current of this circuit is from D to C to B to A. उल्टा. तो साइंटिस्ट ने थोड़ा सोचा और डिसाइड किया कि रहने दो, उल्टा कोई फर्क नहीं पड़ता. Therefore, तुम्हारा हेडेक बढ़ता है. What is the flow of electron पूछा तो it is ABCD. But the direction of electric current is always opposite to the flow of electron, therefore it is DCBA. Remember this. 2-mark question will come, and the proof of that question is here. Conventionally, in an electric circuit, the direction of electric current is taken as opposite to the direction of flow of electrons, which are negative charges. शांति से पढ़ो, ये पॉज करो और समझो. फ्लो ऑफ इलेक्ट्रॉन जहां पे भी है उसके ऑपोजिट डायरेक्शन में फ्लो ऑफ करंट माना जाता है. क्यों? बिकॉज सालों पहले इलेक्ट्रिसिटी को माना जाता था फ्लो ऑफ पॉजिटिव चार्जेस. फ्लो ऑफ पॉजिटिव चार्जेस मानते थे, बट वो गलत निकला. इट इज एक्चुअली फ्लो ऑफ नेगेटिव चार्जेस. ओके, टेकिंग अ स्टेप अहेड. ये देखो, यहाँ पे कोई बैटरी नहीं है. चार्जेस आर रैंडमली मूविंग, देयरफॉर नो इलेक्ट्रिक करंट. बट जैसे ही बैटरी अटैच की, बैटरी का इंटरनेशनल सिंबल इज अ बिग लाइन एंड अ स्मॉल लाइन. बिग लाइन इज ऑलवेज द पॉजिटिव साइड ऑफ द बैटरी, स्मॉल लाइन इज द नेगेटिव साइड ऑफ द बैटरी. और जब बैटरी से वायर अटैच करते हैं, द इलेक्ट्रॉन सडनली स्टार्ट टू मार्च in a particular direction. Can you guess that electrons are marching in which direction? The electrons are marching from the negative terminal of the battery towards the positive terminal of the battery. Why? Because minus plus attract each other. It's a normal law of science. Opposite charges attract, सेम चार्जेस रिपेल. मैग्नेट्स में देखा होगा, नॉर्थ एंड साउथ चिपक जाएंगे, बट नॉर्थ नॉर्थ होगा तो रिपेल करेगा. सो नेगेटिव लव पॉजिटिव, देयरफॉर नेगेटिव इलेक्ट्रॉन्स आर रनिंग टुवर्ड्स द पॉजिटिव टर्मिनल ऑफ द बैटरी. इफ somebody asks me that look at the diagram and tell me What is the direction of flow of electrons? If somebody asks me flow of electron ka direction, I will say this is the direction. But that means that the flow of electric current, flow of I, electric current, is considered as like this inside the wire. Ulta. अब चार्ज की कहानी. What is a charge? Imagine a vein or an artery. Vein or artery में blood is flowing. But when we say blood is flowing, technically we mean RBCs are flowing. In the same way, in an electric wire, we say electrons are flowing. But all electrons have a charge. Therefore, we say charge is flowing. How is this charge counted? Charge is counted by counting the number of electrons. क्योंकि हर एक इलेक्ट्रॉन के पास खुद का एक चार्ज होता है which is -1.6 into 10 raised to -19 coulomb. ये चार्ज का यूनिट है. Every electron. Like every human being has a name, every human being has a surname, he has a passport number, he has a PAN card number, he has mass, he has a certain height. तो हर एक ह्यूमन बीइंग का कुछ चीजें होता है उसके पास, वैसे एक चार्ज होता है. और चार्ज एक ऐसी चीज है जो इलेक्ट्रॉन के पास है, and the value of that charge is -1.6 into 10 raised to -19 coulomb. तो प्रोटॉन के पास भी कुछ होना चाहिए. प्रोटॉन हैज एग्जैक्ट सेम चार्ज, but it is +1.6 into 10 raised to -19 coulomb. और न्यूट्रॉन के पास कुछ होना चाहिए, zero charge. It is neutral. Neutral means no charge, no negative charge, no positive charge. Therefore, electrons and protons both have charges. Up, when electrons start to march in an orderly fashion from left to right or right to left, एक तरीके से मैं बोल सकता हूं electrons are moving, but electrons are moving की जगह I can say charge is moving because every electron has a charge. तो ये बाय हार्ट करो. One electron has -1.6 into 10 raised to -19 coulomb charge. One proton has +1.6 into 10 raised to -19 coulomb charge. And flow of electron matlab flow of charge. And flow of charge is the 3-word definition which I told you 30 minutes before. जब लेक्चर समझाना शुरू किया था, वापस जाओ चाहिए तो रिवाइंड करके देखो, सुनो, समझो. इलेक्ट्रिसिटी का डेफिनेशन, इलेक्ट्रिक करंट का डेफिनेशन इज 3 words, फ्लो ऑफ चार्ज. और चार्ज है इलेक्ट्रॉन के पास, देयरफॉर फ्लो ऑफ इलेक्ट्रॉन्स.
Previously, we talked about how electric charges can build up on surfaces and create something known as static electricity. In this episode, let's talk about what happens when these electric charges continuously move in a process known as current electricity. Most electronics, everything from your refrigerator to your smartphone, requires current electricity to operate. Let's assume that we have a copper wire that's filled with copper atoms. Copper is one of those elements that has only one electron in its outermost shell, which means that with only a little energy, that electron can be easily ejected. If we push a free electron into the copper wire, it will eventually find a new atom to latch onto. The negative charge of that electron will eject another electron from the outer shell, which will then move on to the next atom, and so on and so on. This chain of moving electrons creates a flow known as electric current. Some elements, like copper, aluminum, and gold, can move electrons easily and are known as conductors. We can look at moving charges in another way. Let's say that this tube is a conductive wire and the steel balls are negative electric charges, electrons in this case. We might think that one charged particle needs to move completely through the conductor to create a flow, But that's not actually the case. As we push a ball in one end, the force causes all the balls to move and one pops out the other end. As you can see, one electron, even if it doesn't move very far, can force all the other electrons to move, creating a flow. What we just showed was electric current, which is a flow of electric charge. In most circuits, this is accomplished by moving electrons. The unit for measuring current is the ampere, which is often abbreviated as amps and written with a capital A. 1 ampere is defined as 1 coulomb of charge moving past a point per second. Let's look at a cross-section of wire carrying an electric current. If it takes 3 seconds for 6 coulombs of charge to move through that cross-section, then we say that 2 amps are moving through that wire. Unfortunately, electric current doesn't just magically flow through wires. It needs a little help. If left alone, the electrons in a wire won't move. We need to give them a little push. To do that, we'll use a voltage source like a battery. In a battery, there is a buildup of negative charge on one side in the form of excess electrons. The other side has a buildup of positive charge, an absence of electrons in this case. The charges want to balance out, but the only way to do that is for the excess electrons to flow around the battery through a conductor that we provide. If we connect a piece of wire to the negative terminal, the electrons will push against the electrons in the wire. However, air is an insulator as its molecules do not have very mobile electrons, and it won't readily accept the free electrons. To show this, we'll put a piece of tape at the end of the tube. Now, the electrons at the end of the wire have nowhere to go. Even if we push against the electrons in the wire, they still won't budge. To fix this, we need to connect the other end of the wire to a place where the electrons want to go, and the positive end of the battery will happily accept the electrons. In fact, don't try this with a real battery. There is nothing slowing down or restricting the flow of electrons, which results in tremendous amounts of energy being transformed into heat in the wire, and this could easily melt the wire insulation or start a fire. This is known as a closed circuit, as it creates a loop from one side of the energy source to the other. If we break the wire or remove it from one of the terminals, then the electrons will stop flowing. This is known as an open circuit. We've been talking about electron flow in a circuit and showing how electrons move from the negative terminal to the positive terminal. However, in electronics, we usually assign current as flowing from positive to negative, or from higher potential to lower potential. This is known as conventional current. In the mid-1700s, Benjamin Franklin theorized that positively charged objects had an excess of what he called electric fluid, and that negatively charged objects had a deficit of this fluid. Franklin noted that this fluid had a tendency to flow from positive to negative to distribute itself more evenly. It wasn't until the end of the 19th century that English physicist J.J. Thomson discovered the existence of the electron. Even though we now know that it is electrons that move inside of most circuits from low to high potential, the convention of current moving from high to low potential stuck. As a result, most current measurements are given as conventional current, which is the movement of positive charge in a circuit, and is represented by the capital letter I. Don't worry, the math still works out as long as we stick with either electron flow or conventional current. And since most electronics textbooks use conventional current, we'll go with that. We talked about making electricity do work for us, and the circuit forms the basis for all modern electronics, everything from the simple flashlight to massive supercomputers. If we made a circuit out of just a battery and a piece of wire, there's a chance we might melt that wire as the electrons move through that wire at an alarming rate and generate massive amounts of heat. In the next episode, we'll talk about the relationship between voltage and current and introduce the resistor.
Do you recognize the person you see on your screen? Yes, he is the great Thomas Edison. Do you know what he is known for? In 1879, he invented the first practical, long-lasting electric light bulb. And since then, our homes are bright even after sunset. You must be aware of the fact that lights in our homes work on electricity. However, they're not the only ones that use electricity. Our televisions, air conditioners, water heaters, fans, and so on also need electricity to function. Laser light or even small flashlights also work on electricity. Imagine a life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. But let's just keep aside all the rhetoric talks and try to understand the real thing. I haven't really told you what the term electricity means. Well, there are basically two forms of electricity. One is static electricity and the other is dynamic electricity. For now, we are only interested in dynamic electricity. From the name itself, we can say that it implies moving electricity, or more precisely, moving electric charges. Now the next question you have will be, what are electric charges? The concept of electric charges is very important in physics and it cannot be explained in a video or two. But I will still try to give you a short and to the point explanation of this concept. So let's begin. There are two types of electric charges. Positive, denoted by the plus sign, and negative, denoted by the minus sign. Think of magnets for a moment. We know that two like poles, that is, two north or two south poles of magnets, repel each other. And unlike poles attract each other. Similarly, like charges, that is, two positive or two negative ones, repel each other, and unlike charges, that is, a positive and a negative one, attract each other. But what exactly is charged? Or in other words, who actually carries these charges? Well, these charges are carried by tiny particles with incredibly small mass. They are called subatomic particles. The positive charges are carried by particles called protons, while negative ones are carried by particles called electrons. There are billions and trillions of protons and electrons present in any object around us. In some objects like metals, electrons can move randomly. While in non-metals, their position is kind of fixed and hence they cannot move freely. Now, any appliance in our house, for example a tube light, works because the negatively charged electrons are moving in the wire in one direction. This unidirectional motion of electrons in a wire is also called electric current. These wires are made of metal, usually copper or aluminium, and you can understand why. But why are the charges in a wire moving in one direction? Or what makes the charges move in the wire? The charges move in one direction in the wires because of the energy supplied to them by the transformers. So the transformer supplies energy, the charges move in a wire, which in turn makes our appliances work. A flashlight also works in the same way. But here the energy is supplied by the two electric batteries. So to sum it all up, dynamic electricity is flow of electric charges through conductors like, say, a copper wire. Generally, when we talk about electricity or electric current, we mean dynamic electricity. Hence, we simply say that electricity is nothing but the flow of electric charges through a conductor. In the next video, we will learn how to light up a small torch bulb using a single electric cell. So see you there.
Entering the more technical part of electric current. Flow of charge. We have seen electrons have charge, how much charge we should by heart. Electrons have minus 1.6 into 10 raised to minus 19 coulomb, C-O-L-O-U-M-B of charge. Coulomb is the SI unit of charge. So one electron has minus 1.6 into 10 raised to minus 19 coulomb, and one proton has plus 1.6 into 10 raised to minus 19 coulomb, or simply C. This is very small. 1.6 into 10 raised to minus 19 matlab 0. 0.000000000000 कितना छोटा नंबर है, विच मीन्स एक इलेक्ट्रॉन में बहुत कम चार्ज होता है, एक प्रोटॉन में भी बहुत कम चार्ज होता है. तो सोचो एक कोलम चार्ज इकट्ठा करने को कितने इलेक्ट्रॉन्स लगेंगे. 1 कोलम चार्ज इकट्ठा करने के लिए कितने इलेक्ट्रॉन्स लगेंगे? बहुत सारे, अप्रोक्सीमेटली 6.25 into 10 raised to 18 इलेक्ट्रॉन्स। तो एक इलेक्ट्रॉन में इतना कम चार्ज है कि 625 इतने इलेक्ट्रॉन्स इकट्ठा होंगे तो एक कोलम चार्ज इकट्ठा होगा। And do you know that one coulomb charge has to pass in 1 second? Then it will create a current of 1 ampere. So electric current की कुंडली बना रहे, electric current symbol symbol of electric current is I. Formula I is equal to Q by T. Definition of electric current is flow of charge in unit time. मतलब 1 सेकेंड में कितना चार्ज पास हो सकता है, therefore it is Q upon T. What is Q? टोटल चार्ज। और टोटल चार्ज किससे बनता है? नंबर ऑफ इलेक्ट्रॉन से। तो एक एक इलेक्ट्रॉन पास होते जाता है, वैसे चार्ज बढ़ते जाता है, और जैसे चार्ज बढ़ता है करंट बढ़ता है, बिकॉज करंट इज चार्ज अपॉन टाइम। I is equal to Q by T. But what is total charge made up of? It's made up of Ne. N मतलब number of electrons, E मतलब charge of one electron. Number of electron into charge of electron 1.6 into 10 raised to minus 19 coulomb. It's all very complex, but you will have to learn them. 2 बार वीडियो देखो, 1 बार टेक्स्ट बुक पढ़ो, प्रेसी नोट्स मिलेगी, slowly and steadily you will understand everything. फिलहाल I am starting from basics once again. Wire is made up of metal. Metal has protons, electrons. Electrons have a negative 1.6 into 10 raised to minus 19 coulomb charge. एक इलेक्ट्रॉन के पास ई चार्ज, तो n इलेक्ट्रॉन्स के पास कितना चार्ज? एक इलेक्ट्रॉन के पास E, तो n इलेक्ट्रॉन्स के पास कितना? Ne. That's the total charge Q. Q is equal to Ne, मतलब नंबर ऑफ इलेक्ट्रॉन्स इंटू 1.6 इंटू 10 रेज टू माइनस 19, यहाँ पे माइनस आएगा, और वो टोटल चार्ज कितने टाइम में पास होता है अपॉन टी, दैट्स कॉल्ड इलेक्ट्रिक करंट. इलेक्ट्रिक करंट इज वायर को बीच में से काट के चेक करो कि कितना चार्ज पास हुआ कितने टाइम में, and the amount of charge passing in some time is called electric current. इलेक्ट्रिक करंट की कुंडली में एक और चीज, ऐसा यूनिट ऑफ करंट इज एम्पियर, AMPERE. और ये एम्पर का इन्वेंशन कैसे हुआ? इट्स वेरी सिंपल, फ्रॉम द फॉर्मूला ऑफ इलेक्ट्रिक करंट. इलेक्ट्रिक करंट I is flow of total charge upon given time. Total charge is measured in coulomb. Time is measured in second. Therefore, coulomb per second is the unit of current. और coulomb per second को हम प्यार से A बुलाते हैं, और A मतलब एम्पियर. So just in this one slide, last 40 minutes of discussion has become completely technical. So electric current symbol I. Current is charge passing through a conductor in given time. Therefore, charge upon time. Charge matlab Q, and charge Q is made up of number of electrons and individual charge of one electron. So please make sense of this. It's tough, but वापस वापस देखो, बाहर के वीडियोस देखो तो धीरे धीरे समझ में आएगा. So finally going back to the textbook, if a net charge Q, मतलब total charge Q flows through any cross section of the conductor in time t, मतलब वायर के किसी भी पार्ट से Q चार्ज फ्लो हो रहा है in t time, then current I is defined as I is equal to Q by T. And SI unit of electric charge is coulomb, COULOMB. I think I was using wrong spelling till now. You correct it. तो Q का यूनिट इज कोलम और T का यूनिट इज टाइम, मतलब सेकेंड्स, और कोलम पर सेकेंड मतलब एम्पियर. And this ampere is named behind a scientist called Andre Marie Ampere. He was the one to find out lot of details about electricity. वन कॉलम में कितने इलेक्ट्रॉन्स होते हैं? 6 इंटू 10⁻18. मैंने 6.25 लिखा था. दैट इज ऑल्सो ट्रू. दैट इज मोर प्रिसाइज फिगर. दिस इज टेक्सचुअल, देयरफॉर यू हैव टू बाय हार्ट दिस कि एक कॉलम चार्ज में 6 इंटू 10⁻18 इलेक्ट्रॉन्स होते हैं with an individual charge of 1.6 into 10 raised to minus 19. Andre Marie Ampere, 1775-1836. Therefore, how do you define 1 ampere current? 1 ampere electric current का मतलब है कि वायर के थ्रू 1 coulomb charge is passing in 1 second. 1 coulomb per second is 1 ampere. तो मिली एम्पियर कितना होता है? 1 एम्पियर की जगह 1 मिली एम्पियर कर दो. इट इज इक्वल टू 10⁻³ एम्पियर, मतलब 0.001 एम्पियर, विच इज लेस. और मिली एम्पियर से भी कम माइक्रो एम्पियर इज 10⁻⁻6 एम्पियर, दैट इज 0.000001 एम्पियर. इतने में खत्म होता है इलेक्ट्रिसिटी में इलेक्ट्रिक करंट का कुंडली. हाउ डू यू मेजर इलेक्ट्रिक करंट? बाय समथिंग कॉल्ड एज एमीटर. तो एमीटर से इलेक्ट्रिक करंट हम मेजर कर सकते हैं बाय पुटिंग इट इनसाइड द सर्किट. इट विल कंटिन्यूअसली शो हाउ मच इलेक्ट्रिक करंट इज फ्लोइंग. Write down the formulas. I is equal to Q by T. मतलब करंट is equal to total charge upon time. फिर I is measured in ampere. AMPERE, short form A. Example 12 ampere current. I मतलब current. Q is measured in, Q मतलब total charge, it's measured in coulomb. C. Example 2 coulomb charge. N is number of electrons. E is minus 1.6 into 10⁻⁻19 coulomb. और यहाँ पे Ne by T. तो I is equal to Q by T और I is equal to Ne by T से हम सॉल्व कर सकते हैं कुछ न्यूमेरिकल्स. A current of 0.5 ampere, I 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. Time 10 minutes, but minutes नहीं यूज करते, seconds यूज करते हैं. 600 seconds. Find the amount of electric charge flowing through the circuit. Q पूरे सर्किट से कितना चार्ज पास हुआ अगर 0.5 एम्पियर करंट 10 मिनट तक चालू था. I is equal to Q by T. 0.5 is equal to Q by 600. 600 into 0.5. 300 coulomb charge passed through the circuit in 10 minutes. Easy. Formula याद रखने पड़ेंगे. 300 coulomb. देखो टेक्स्ट बुक ने क्या किया है, Q is equal to IT यूज किया है, बट Q is equal to IT की जरूरत नहीं है. You remember just one formula, the main formula. If electric current, you will get the same result. I is equal to Q by T. What does an electric current mean? What does an electric circuit mean? Electric circuit means wires which are connected to the batteries where flow of electrons is achieved. बहुत सारे अलग अलग डेफिनेशन है, तुम कुछ भी लिख सकते हो, but it has to be correct. Define unit of electric current. Unit of electric current is A, whose full form is ampere, which is coulomb per second. And calculate the number of electrons constituting one coulomb charge. एक coulomb charge में कितने electrons होते हैं? तो one electron gives minus 1.6 into 10 raised to minus 19 coulomb charge. Then how many electrons will give me 1 coulomb charge? We have to cross multiply. 1 into 1 upon minus 1.6 into 10 raised to minus 19. आंसर बाय हार्ट कर लो. 6 into 10 raised to 18 इलेक्ट्रॉन्स. इतने इलेक्ट्रॉन्स होते हैं एक कोलम चार्ज में. This is where we stop. We will do electric potential next time. Thank you so much. Circuit construction kit. DC. So you have to open this in Chrome. The link is phet.colorado.edu, and in that you will find out this circuit construction kit. But let me show you actually how to start from the beginning. Just go to google.com. This 99% will work only on your laptop. So you have to write here electricity simulation. इलेक्ट्रिसिटी सिमुलेशन सर्च करने पे जो पहला लिंक है phet.colorado.edu, and there you have to just play this press this play button, nothing else. It will automatically start to open in the Chrome window. Intro and lab, you will see two options. When you press intro you will get something. Lab, you get more options. So intro and lab can be changed from bottom also. I am going to keep lab because it is more interesting. The step number 1 of making a circuit or understanding electricity is having a wire. You can break the junction. You can keep a switch which you can on and off. Battery and more wire, and this is circuit is complete. Now switch is on. This is called switch is closed. When switch is closed, the electrons move, and when electrons move, there is electric current. So there is electric current passing through the wire through the battery, all thanks to the battery. बट ये आग क्यों लग गई है? क्योंकि हमने बैटरी के दोनों एंड्स को डायरेक्ट वायर के साथ अटैच कर दिया. दिस इज कॉल्ड शॉर्टिंग द बैटरी. दिस इज कॉल्ड, मान लो कि तुम्हें प्यास लगी है. अगर किसी आदमी को प्यास लगती है तो क्या वो बिल्डिंग की टंकी में डुबकी मारता है? नहीं. अगर किसी इंसान को प्यास लगी है तो क्या डैम के दरवाजे खोलता है? नहीं. ये हमने डैम के दरवाजे खोल दिए. देयर वर सो मेनी इलेक्ट्रॉन्स इन द बैटरी एंड वी डायरेक्टली अटैच्ड द वायर. तो उसके भरे हुए कंपार्टमेंट से खाली कंपार्टमेंट में इलेक्ट्रॉन भागने लगे. देयरफॉर दिस इज रॉन्ग. दिस शुड नॉट बी डन. देयरफॉर आई एम गोइंग टू कट द सर्किट हियर एंड अटैच अ रेजिस्टर. रेजिस्टर का काम क्या है? टू स्लो डाउन द फ्लो ऑफ इलेक्ट्रॉन्स. ये रेजिस्टर का काम है टू स्लो डाउन द फ्लो ऑफ इलेक्ट्रॉन्स. फ्लो ऑफ इलेक्ट्रॉन्स मतलब इलेक्ट्रिसिटी, और इलेक्ट्रिसिटी एमीटर से मेजर होती. ये रहा करंट मेजर करने वाला एमीटर. इसको तोड़ते हैं और इसको यहाँ पे लगाते. यू सी द करंट मेजर्ड इज 0.9 एम्पियर्स. रेजिस्टेंस कितना है? 10 ohms. तो रेजिस्टेंस इज अ स्पीड ब्रेकर और ब्रेक्स जो करंट को स्लो करती है, मैनेजेबल करती है. अगर मैं रेजिस्टेंस कम करूँ, 10 ohms की जगह पे 6.5 ohms करूँ, तो द फ्लो ऑफ करंट विल इंक्रीज 1.38 हो गया. फर्दर रिड्यूसिंग, यू सी द स्पीड इज इंक्रीज्ड and the current has increased to 9 amperes. Resistance और कम कर दिया. This is so less resistance कि इलेक्ट्रॉन्स बिना कंट्रोल के भाग रहे. Therefore थोड़ा सा बढ़ा दो. This is 1 resistance, current 9. I am increasing the resistance, the current is decreasing. बहुत हाई रेजिस्टेंस होगा 120 ohms, तो करंट विल नॉट फ्लो एट ऑल. टू मच रेजिस्टेंस मीन्स यू आर जस्ट नॉट अलाउिंग द करंट टू फ्लो. इसलिए करंट है 0.07 एम्पियर्स, विच इज सो लेस कि कोई काम नहीं हो सकता. बट कौन सा काम? वो तो हमने सोचा ही नहीं. कौन सा काम देखते हैं. ब्रेक द सर्किट फ्रॉम हियर. और काम है बल्ब का. वी वॉन्ट लाइट. आई थिंक अरे वाह, यही तो चाहिए था. ओके. अबे see, is the bulb glowing right now? No, the switch is closed. मतलब स्विच ऑन है. स्विच को हटा दो, स्विच की ज़रूरत ही नहीं है. डिलीट, डायरेक्टली ज्वाइन. 0.07 एम्पियर पे बल्ब डज नॉट शो एनी लाइट. रेजिस्टेंस इज टू हाई. मैं रेजिस्टेंस को कम करता हूँ. अब देखो बल्ब में लाइट आ गई एंड द इलेक्ट्रिक करंट हैज स्टार्टेड टू मूव, बट इट्स लेस करंट, देयरफॉर लेस लाइट. रेजिस्टेंस कम करो तो करंट बढ़ेगा. करंट बढ़ेगा तो यू सी द लाइट. एंड वेरी लेस रेजिस्टेंस मीन्स मैक्सिमम करंट. द बल्ब ग्लोज फुल्ली. दिस इज कॉल्ड electric current, resistor, emitter to measure the current. अब एक चीज होती है वोल्टेज. वोल्टामीटर शोज यू द वोल्टेज, और वोल्टेज बैटरी का होता है यू सी 9 वोल्ट. इसको छोटा कैसे करे. या 9 वोल्ट Voltage means the battery is providing the push of 9 volts और 9 वोल्ट पुश पे 0.9 एम्पियर करंट है और रेजिस्टर कुछ 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 कार्यक्रम चल रहा है. So this is overall explanation. You can play with this more and more. The more you play, more you will understand the relation between resistance, voltage and current.